All right, guys, for 9.4, we're going to get into some inscribed angles, and I'll tell you what that means in just a minute. But for today, we have two things that we got to get done. One, we have to be able to find measures of inscribed angles, and two, we need to find measures of angles of inscribed polygons. So those are two objectives for our day. Let's check it out. 9.4, inscribed angles. So an inscribed angle is an angle in which the vertex on a circle and sides that contain chords of the circle. So basically, a picture would be helpful here. The vertex is on the circle someplace, all right? So we could say the vertex is right here, for instance. And then the sides contain chords of the circle. Okay, so we might have an angle that's like this, for instance. That's called an inscribed angle. So up until this point, you guys, just so that we're clear, in the first lesson, we looked at what we called a central angle, where we looked at an angle from the middle. Now we've pulled that center back. Okay, and now we're looking at an angle from this perspective. All right? So that's the difference here. This is called an inscribed angle, and it acts a little bit different than the central angle. So we're going to get into some rules of that. Okay, so there are three ways angles could be inscribed. One of which is we have a vertex, and then we have one of the sides of that angle that is a diameter, right? So it goes through the center. Then we have another one where the center is inside the angle. Okay, then we can have an inscribed angle in which the center is on the outside. All right, so there's three different ways that this could happen. And those will become important a little bit later, but they all follow similar rules. The intercepted arc is the other thing that you need to know about. It has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. So basically what this is saying is this. An intercepted arc is if we have an inscribed angle like this, okay, this arc here, from here to here, the yellow part is called the intercepted arc. It has endpoints on the sides of an inscribed angle and lies in the interior of that inscribed angle. Okay, so that is what an intercepted arc is. All right, now that we've gotten some vocab out of the way, let's get into the first theorem. So the inscribed angle theorem, theorem 9.6, says if an angle is inscribed on a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. Okay, so here, for this example, it says if AB, okay, so AB is this guy right here. If arc AB, it should be arc is what it should say. If that is 80 degrees, okay, then the measure of angle 1, okay, back here is 40. Now, how that's different from what we've done before is this. Before, we had a central angle, and whatever that angle was in the center here, it was the same on the outside. So like say this was like 70 here, then this was 70, right? That was a 1-to-1 relationship. Now that we've pulled that back to the outside, now the relationship is half. Okay, so now it's half. The inscribed angle theorem, 1/2 the measure of its intercepted arc. Okay, so example 1 says, what is the degree of arc CF? So that's this guy in yellow right here. If we know that that inscribed angle is 40, right? So this angle here is 40. We know that since that's inscribed, that this would have to be double that, right? Which would be 80. So this would be 80 degrees. And then it says, what is the measure of angle C? If we know that so let me just erase all this stuff here so we can focus on the next question. So what is the measure of angle C? That's this guy right here, question mark. What is the measure of that guy if it creates an arc on the other side that is 98 degrees? So this yellow part here is 98 degrees, which means that that C angle would have to be half of that, right? So half of 98, 98 divided by 2 is equal to 49 degrees. And we're done. Okay, so that's example 1. Then theorem 10.7 tells us a little something else. Very similar, though. It says if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So basically what this is saying is, look, if you followed the blue lines, okay, if you followed C here, this blue angle here, it intercepts this arc AD, right? Then if you follow the red lines here, it intercepts the same arc AD, right? So that means that these angles have to be the exact same. So two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So we know that because of the rule, right? So, and it'll be exactly half of whatever AD is. So let's look at this and do an example with this. So example 2 says, if the measure of angle S is 3x, so this is 3x, and the measure of angle V is x plus 16, find the measure of angle S. So we can basically find x there and then plug it back in, right? So let's look at this. If we look at angle S, right, it's this angle, it intercepts TU. And then if we look at angle V, it's this angle, which also intercepts TU. So we know that those two things have to be congruent. All right, so we don't need this information for this particular problem here. All right, so we have 3x has to equal x plus 16. All right, so let's just solve this real quick. So we subtract x from both sides. We get 2x is equal to 16, so x is equal to 8. Therefore, angle S, the measure of angle S is equal to 3 times 8, because it's 3x, okay, and x is equal to 8. So the measure of angle S is equal to 24 degrees. That's example 2. Now we have 2 more theorems here, so we'll do theorem 10.8. Okay, all of these are very similar though. Okay, so they're very similar ideas. This one says an inscribed angle of a triangle intercepts a diameter or semicircle if and only if that angle is a right angle. Okay, so this makes sense, right? Because we know that if this is an inscribed angle, that this guy here is 1/2 of the arc that it creates, right? So if the arc that it creates is 180 degrees, if FH is a semicircle, which is 180 degrees, then this has to be 90. Okay, it's the same exact theorem. This is just a specific case in which we have a semicircle now. Okay, so that's all this is saying. So example 4 says if the measure of angle F is 7x plus 2. So notice I crossed these out here. So this is actually 7x plus 2. And the measure of angle H is 17x minus 8. Find the measure of, or it says find x, right? So let's just take a peek at this. We know that F, the measure of angle F, gives me this intercepted arc GH, right? And then we know that H, the measure of angle H, going from this perspective, will intercept GF. So together, they create a semicircle of 180 degrees. Okay, but remember, these are inscribed angles, so it's actually half of that, right? It's half of that. So what I need to do to solve this is I need to say, okay, 7x plus 2 plus 17x minus 8. So the two combined, this angle and this angle, those have to equal 90 since the arcs that they produce equal 180, right? So let's do combining some terms here so we can combine some things. 17 plus 7 gives me 24x. 2 minus 8 gives me -6 equals 90. So I can add 6 to both sides. I get 24x is equal to 96. Divide both sides by 24. And I get x is equal to, I believe that comes out to 4. Okay, so x is equal to 4 for example 4. A lot of 4s going on. Okay, the last theorem, you guys, and then you guys will have all the tools you need to get this homework done, is theorem 10.9. This says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Remember what supplementary means? Supplementary means they add up to 180 degrees, right? So it's that word supplementary, 180 degrees. Okay, so basically what I want you to see is, if you have a quadrilateral in here, if you're looking at this angle, M, and you're looking at this angle here, K, if you were to add the two together, notice what happens here. If you look at M, just so you guys see this, if you look at this measure of M, it gives you this arc LN, right? And then if you look at K, I'll do this in blue. So K is this guy. Ooh, that's a little too thick, sorry. Then that gives you this piece. So together, those two give you the whole circle. So together, those two angles have to be half of 360 degrees, which is 180. All right, so that's the rule with the quadrilateral that's inscribed inside a circle. And it would be true if we would have looked at N and L as well. And I'm trying not to use these angle signs because I don't want you to think those are congruent. Those add up to, L and N add up to 180, right? K and M add up to 180. Okay, so for example 5, it says quadrilateral WXYZ is inscribed inside the circle. Find the measure of angle X and the measure of angle Y. All right, so again, if we looked at angle W here, it's this piece right here. And then that forms the arc that is ZX, right? Okay, so I know that that arc has to be double this guy. Okay, so, you can double that out. But then Y, this guy, which I don't know, inscribes, check this out, inscribes the rest of the circle. Okay, so together, what I know is angle W plus angle Y has to equal 180 degrees. And I know what angle W is. It's 95, so I can plug that in. So 95 plus angle Y is equal to 180. Solve for Y. So angle Y has to equal, if you subtract 95 from both sides here, and we get that angle Y is equal to 85 degrees. All right, and that is it, guys. So that's all the theorems, all the examples you need to do your homework. You have your homework sheet from last time. We'll catch you guys next time in class.